In this tutorial, you will learn to create a full-stack web application from scratch using Microsoft SQL Server for the database, .NET Core Web API for the backend, and React.js for the front end. We will first start with creating the necessary tables in Microsoft SQL Server, then create the Web API project with the required REST API endpoints. Finally, we will use React.js for creating the front end. You will learn how to add routing for our app. Create Bootstrap table with custom sorting and filtering capabilities. Add modal pop-up windows with drop-downs and date pickers. We will also learn how to upload an image and store it in the backend server. Welcome to the course and happy learning. Let's install Visual Studio. You can choose to install the community version, which is free to download and use for educational purposes. Run the installer file. I have already installed Visual Studio, but if you are installing for the first time, you will be presented with this screen. You can choose ASP.NET and Web Development, .NET Desktop Development, and .NET Cross-Platform Development and click on Install button, which appears in bottom right. The installation will take quite some time as the IDE is big. Let's install Visual Studio Code. Visual Studio Code is a popular lightweight code editor from Microsoft. It is mostly used for front-end web development. Let's install Postman. We will be using Postman to test our REST APIs. Let's install SQL Server Management Studio, which is used to work with SQL Server database. Run the installer file. You can keep the default options and click on Install. It's asking me to restart the PC. Let me do it. I am running the installer again after restarting. The setup is now complete. Let me start SQL Server Management Studio. I have already procured a Microsoft SQL Server and a database using Microsoft Azure. I will use the same. You can also create a local server and database by installing the developer edition of SQL Server. We are now ready to create the necessary database objects. Let's install Node.js. To verify the installation, we can just check the npm version. Let's create the database tables required for our app. We can see that currently we don't have any tables. We need 2 tables for our app. One to store department details and another one to store employee details. Let's start with department table. This table will have 2 fields. One to store an auto-generated table ID and another one to store the department name. Let's insert some records using insert query. Now let's check the data in our table using select query. Let us similarly create table to store employee details. We will be storing employee ID, employee name, department to which the employee belongs to, the date of joining, and also the uploaded profile picture file name. Let's insert a record. And check data using select query. We have now successfully created the database objects needed for our app. Let's create the .NET Core Web API project. Let's open up Visual Studio first. Click on Create a new project. Choose ASP.NET Web API Core. Choose appropriate folder. We might not need HTTPS for now. Now let's take a look at some of the important files. All the dependencies and packages needed for our app can be found in the Dependencies folder. Launch settings.json file contains the details of how the project should be started. Controllers folders contains controllers in which we write our API methods. We generally keep the configuration details such as database details in app settings.json. The program.cs contains the main program, which is the entry point of our app. Also, it creates webhost, which basically helps the app to listen to HTTP requests. The startup class configures all the services needed for our app. Services are basically reusable components that can be used across our app using dependency injection. It also contains the configure method, which creates our app's request processing pipeline. We need to make a couple of changes in startup class. One is to enable the cores. By default, all Web API projects come with a security which blocks requests coming from different domains. We are basically writing instructions to disable that security and allow the requests to be served. We are also making one more change to the serializer class to keep the JSON serializer as our default. We might need to install a NuGet package to do this. Let's import the namespace. Now let's simply run the project and check if everything works fine. We see that the project works as expected, and we see the JSON result from one of the sample controller method. Now let's create the models needed for our app. Let's create a folder to add our models. Let's add the department model. Department model has two fields: department ID and department name. Next, let's add the employee model. It has 5 fields: employee ID, employee name, department, date of joining, and photo file name. Let's start creating the API methods. Let me first add the SQL Server connection string in app settings JSON file. Now let's add an empty controller to write our API methods for department details screen. To work with SQL Server, we need to install a NuGet package. The package name is system.data.sql client. Let's also import the namespaces. To read the connection strings from app settings file, we need to make use of dependency injection. Now let's write an API method to get all data from department table. I am writing raw queries here. You can choose to write stored procedures or maybe use entity framework for this. I will be getting the data into a data table object. Using the given SQL connection and command, we will execute our query. And fill the data into data table using SQL Data Reader. Finally, we will return this data in JSON format. Let's test this API method. This seems to work. Let's now add the post method to insert new record into department table. We will be sending the department object to our post method in the form body. Let's also create the put method to update records. And finally, let's implement the delete method. Now let's test our API methods. We will be using Postman to test since we can test only get method in the browser. The get method seems to be working. Let's add another department using post method. Looks like we are not sending success message after adding. Let's try again. We see that the record is added successfully. Let's verify this. Now let's use the put method to update a record. The put method also works as expected. Now let's check the delete method. We need to make some changes to the delete method to accept the ID and URL. We see that the delete method also works as expected. Let's implement the API methods for employee details screen. Let's add an empty API controller. Let's copy the contents from department controller and make changes accordingly. Now let's test our APIs. The get method works fine. Let's test the post method to insert a record. Post method works fine as expected. Now let's test the put method and update a record. And finally let's test the delete method. The delete method also works as expected. Let's now write an API to upload the photos. Let's create a folder to store photos. To be able to use this folder to store and retrieve photos, we need to add some instructions in the startup class. Now let's write the API method. I am giving a custom root name for this method, and this is a post method. If there is any exception while saving file, I will simply return the default anonymous picture file name. We are going to extract the first file which is attached to form data. We need to again use the dependency injection to get the application path to Photos folder. Once the file is saved, we will simply return the file name. Let's now test the API by uploading an image file. We see that the upload was successful and we can see the image in the newly created path. Let's create our React.js project. Open up command prompt in the desired folder and type the command npx create React app and the name of the app. Let's navigate inside the project and open up Visual Studio Code. Let's simply run the project and see how it looks. Just type npm start. What you see on the screen is the default template that gets added when we create new project. Index.html is the file that gets finally rendered on the screen. Observe that it has a div with ID root. In index.js, we can see that the contents of our app component is injected into the div with ID root. So app.js is our root component, and what you see on the screen comes from this file. Let's delete the content and add an heading tag. Let's install Bootstrap for styling. Copy the style sheet reference and add it in the head section. The bundle reference can be added near the closing body tag. We see that our heading with Bootstrap styling is getting displayed. Let's start adding the routing for our app. We need to install an npm package called React Router DOM to add routing for our React app. Now let's add the components or the pages for our app. We will need 3 components. One for homepage, one for department details, and another one for employee details. Let's add contents in home component. The HTML can be defined in render method. Let's add similar content for department and employee component. Now let's add the navigation menu with routing. Let's import all these components. Also, let's import the modules needed for routing. Now let's add the navigation menu. In the switch tag, we can define the route paths. /home will be routed to home component. /department for department component. And /employee for employee component. Let's start the app and check if this works. We see that the routing works as expected. Let's create a file to store our API endpoints. Let's import it in the department component. Let's create a constructor to define the state variables. The super props is basically used to call the constructor of its parent class. In state, we will be defining an array called departments which will be populated with the department's data from API. Let's now add HTML to display departments data in a bootstrap table. We will be using map method to iterate and display data. Along with department ID and department name columns, we will also have options column to edit or delete records. Let's add bootstrap icons for edit and delete. Now let's add the method to refresh the department's data from the get API method. Once the response is available, we convert it to JSON and assign it our array. We will call the refresh method once the component is mounted. We need to also declare the state variables in render method to use it inside HTML. We see that the table now displays data as expected. Let's add the modal pop-up window with form fields to add or edit departments. Let's define the variables that we are going to use in the modal window. Now let's add the HTML code for Bootstrap modal window. The title of the modal will come from variable. We will have one text box to add or edit department name. When the value of the text box changes, we will execute a function and update the variable simultaneously. We will have a button to create new department. This will be visible when user wants to add new department. The update button will be visible when the user wants to edit a department. Now let's add a button to open the modal window. This will be to add new department. Similarly for editing department. In the add click method, we set the modal title to add department, department ID to 0, and department name will be empty. In the edit click, title will be edit department, and department ID and name will be based on the row data. We see that the modal windows works as expected. Now let's add the methods to create new department by consuming the postDepartment method. We are going to pass the new department name as JSON in the method body. Once successful, we display the message and also refresh the grid. Let's test the method by adding new department. We see that adding new department works. Let's now add the update method by consuming the putAPI method. Let's test it by updating a record. Also, let's implement the delete method. We will be taking user confirmation before deletion. Let's now test the delete method. The delete method also works as expected. Let's now complete the employee details screen. We are going to copy the department component and make changes to it. We will store the data in employees array. In the form fields, we need employee ID, employee name, department, date of joining, photo file name, and the path to photos can be taken from variables file. In refresh method, we are going to refresh both employees and departments array. We are going to use departments array in dropdown. In the modal window, we need to display profile photo as well. So let's use Bootstrap Flex. The image source can be computed from the variables. Department field will be dropdown. The values for dropdown will come from departments array. Date of joining will be a date field. We see that the grid and pop-up window for employee screen works as expected. Now let's implement the method to upload photo. Let's add a button to choose the file input. In the upload method, we will create a form data and attach the first file which was chosen. Once uploaded, we replace the photo file name variable. Now let's test our methods. Let's add a new employee. This seems to work. Let's test the put method and update a record. The put method also works. Let's now test the delete method. We see that the delete method also works as expected. Let's implement the sorting and filtering feature to our grid. We will implement it to the department details page. Let's first create variables to accept filter inputs from user. Also another variable array to store the backup or data without filter. Let's now implement the filter function. We will be using the includes built-in function to check and filter the array. Let's add the text box to accept user inputs for filtering. Once the value in text box changes, we update the filter variable and call the filter function. We see that the filtering works as expected. Let's now implement the sorting function. We will be sending the property name and a Boolean value which indicates whether to sort by ascending or descending. Let's add icons for calling the sorting function. Let's test the feature. We see that the sorting also works as expected.